Hello everyone, my name is Professor Akhil Anjikar from Jhulelal Institute of Technology. Today I'm going to discuss about mm, today I'm going to discuss about subject system programming and topic is microprocessor. So what is microprocessor? When I discuss about the microprocessor, micro means just like procedure or function which is used in programs. Okay, so it contains the number of lines which is repeated in your programming. Okay, so we will make one function for or macro for the number of lines, code of lines which is repeated again and again, and whenever we required to execute those lines we call this macro. So how micro is differ from procedure or function and how it works, we will see in this video. So now micro and procedure or function is same. It contains number of lines or line of code which is repeated again and again. Okay, so difference between function and micro is only that when we call function, the control is transferred to the body of function. But in case of micro, if we define micro, the control is not transferred to the body of micro. Instead of that, body of micro is replaced with the calling statement of micro present in a program. We will see example also, but before that, we will discuss the diagram of that micro. So this is microprocessor. We can see in the diagram. This is microprocessor. What microprocessor do? When your source code contains micro calling statements, means what happen in your code, some number of some line of code repeated again and again. So instead of that line we generate one micro for that lines and call in call this micro in our source code. So whenever this source code going for execution, so in that case source when source code provided to the assembler does not know about the micro calling statements, because micro calling statements is not present in the database of assembler. That's why it will give you error. um, the symbol is not present or illegal symbol. Okay, but what happened when microprocessor process the source code if it contains micro keywords or micro calling statements. When it contains micro calling statement, microprocessor will define some micro data structure and expand the source code and pass to the assembler. Means whatever micro calling statement present in a source code will replace with the body of that micro. Okay, so after replacing body of micro keyword, micro calling statement with body of that micro, so all program is known to the assembler and it is easy to assembler to convert it in a object code. So this is about microprocessor. The main point is that the difference between function and micro is that function, when function called, control transferred to the body of that function. But when micro calls, the body of micro is replaced with the calling statement of micro in a source code. Okay, this is main difference. Now we will discuss about the problem of microprocessor. So when your program contains this macros, wait. There are multiple example of micros, micro inside micro, and micro defining the name of another micro. So this is the one. This is first one. This is the example of micro defining another micro. Why it is called as micro defining other micros? Because it does not contains the name of that micro. When this name of micro define, when OPRTN calls, when OPRTN calls, some value passed to that particular argument, and this value um, will be the name of second micro. What it means that if OPRTN not called, then there is no meaning of that first micro. Okay, if called, then the name of first micro will be decided. Okay, so this is about first micro, and this is the second example of micro within micro, and also you can call nested micro. Okay, so this is second micro. Okay, so this is the body of that micro. Also, when OPRTN calls, the name of that micro will define. Suppose you can see OPRTN add a, the first argument is add. Okay, so the name of that second micro will become add, and also the here is the operation. Previously means before calling OPRTN, which operation perform here uh, is not clear. But when OPRTN call, second argument is a, means operation is a. So when first calling statement OPRTN add a called, then second micro name is add and operation name is a. Second time called sub and s. Micro name is sub and operation is s, means subtraction. So this is about the micro. When and what we have to perform, we have to perform the data structure required to um, replace the calling statement with its body, means OPRTN add a, it replace with its body. Okay, so before we need to define some data structure for microprocessor. So this is about the problem. What we need to define MNT, MDT, ALA. So MNT stands for micro name table. Okay, this is the one data structure. Second data structure is ALA, argument list array, and third one is macro definition table. Okay, so how we define first data structure, MDT, micro definition table. So this is micro definition table. So we will write first micro, first micro, sorry, second micro. We will write first, second micro. So here are the boundary for that. Here are the here is the boundary. Here is the boundary of that micro body. So second statement is OPRT. We will copy this copy the whole body of that micro from second statement to mn. Means how many statements? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so total statements are 8. So second statement, how many statements are there? 8. So these are the 8 statement. But whatever argument pass with OPRTN. So when we write body in that MDT, so instead of that argument, we will write the for first argument #1 and for second argument #2. Okay, and similarly we define other definitions, because this is OPRTN first micro and second micro is the name of second micro is not defined. But when OPRTN called, the the name of second micro will be defined. Okay, so this is second micro when OPRTN add a call. So second micro name will become add. And same procedure for first argument write hash 1, and for second argument I write hash 2. And second is after calling OPRTN sub s. Again second definition will newly defined by sub ampersand a ampersand b. Again same for first argument hash 1 and for second argument hash 2. So this is about the first data structure of microprocessor, MDT, that is micro definition table, and second one is micro name table. So there are three micro, and their name is OPRTN, add, and sub. The MDT index means what is the index of MDT for first micro. First micro start from index 1, and second micro starts from index 9, and third micro starts from index 15. Okay, we can see here 1, 9, 50. Okay, so this is about the MNT. So this is the second data structure of micro processor. And the third one is ALA. ALA stands for argument list array. It contains the argument list for each and every calling statement. The calling statements are add data 1 data 2. Means arguments are data 1 and data 2. So argument list array will become index 1 is data 1 and index 2 is data 2. And same for sub data 1 and data 3. So these are the three data structure used when microprocessor is processing source code. Thank you.